Okay, ready for a deep dive. We're going in deep on materials. And I know what you might be thinking. Materials, really? Sounds kind of dry, right? But hold on, because this is way more interesting than it sounds. And get this, our guide for this journey. A sixth grade science textbook.
Yeah, you might be surprised. These textbooks, they're like hidden treasure troves of really important knowledge. When you think about it, we're surrounded by materials every single day. Understanding how they work, it's kind of crucial, don't you think?
Totally. This textbook, it introduces these two students, Gulan and Shida. They're checking out their new school supplies.
Right, and it's like the perfect example. Backpacks, pencils, lunchboxes, they're all made from different materials, right?
And those materials, they're not just random, are they? They determine how those objects actually work.
For sure. Try writing with a glass pencil or carrying your lunch in a paper bag.
Disaster waiting to happen. So, how does a sixth grade textbook even begin to unpack all this?
Well, they use this activity. It's pretty simple, actually. Students have to group objects, based on what they have in common: shape, color, material.
Kind of like that which one doesn't belong game.
Exactly. It gets you thinking about classification, this fundamental process scientists have been using forever to make sense of the world, and that includes materials.
Right. It's not just about putting things in neat little boxes. Choosing the right material, it really matters. You wouldn't build a skyscraper out of the same stuff as a pillow, would you?
Now you're getting it. That's exactly why understanding the properties of materials is so important. It's all about the right tool for the job, whether it's a skyscraper or a good night's sleep.
Okay, so let's get into some of these key properties. Ready to get our nerd on?
Right on.
All right. First up, we're talking about appearance. This isn't a fashion show, don't worry. But have you ever noticed how some materials, they're shiny, like a brand new car, while others are totally dull, like chalk?
Right, so the textbook, it talks about this as lustrous for shiny stuff and non-lustrous for, the not-so-shiny stuff. They give examples like gold and aluminum for lustrous materials and wood and paper for the non-lustrous group.
Which, when you think about it, makes perfect sense. Can you imagine a dull wooden spoon winning any beauty contests against a shiny new silver one,
Yeah.
even though they're both super useful in the kitchen?
Exactly. And that's the thing, right? Even something as simple as appearance can tell us a lot about how light interacts with different materials. It's not just about aesthetics. It impacts how we actually use those materials, too.
So wait, there's a reason why some things are shiny and others aren't. Like, it's science.
Absolutely. And that's what makes this whole exploration so cool, uncovering the hidden science in the everyday stuff we take for granted.
Okay, so from shiny versus not so shiny, let's move on to something I like to call the scratch test.
The scratch test.
Yeah, when you were a kid, did you ever, scratch things with your house key just to, see how tough they were?
Oh, totally. It's like this, built-in curiosity about how hard things are.
Yeah.
How resistant they are to scratches or dents.
Exactly. And this textbook, they get it. They actually use the example of a metal key scratching wood. And it's true, right? Hardness, it's super important when you think about the stuff we use every day.
For sure. Imagine building a house out of something as soft as a pillow. Wouldn't last very long, would it?
Not a chance. Okay, and while we're talking about everyday experiences, how about transparency? I don't know about you, but this one always takes me back to childhood games of hide and seek.
Oh, yeah. Hiding behind curtains, thinking you're being so sneaky.
And then realizing, wait a minute, you can totally see through this.
Classic.
Yeah.
But it illustrates the point perfectly. The textbook actually uses Gulan and Shida playing hide and seek, talking about how some materials let light pass right through, like clear glass, while others, like a wall, are totally opaque. No light getting through those.
Right, and then there's that in-between zone, right? Translucent materials, like frosted glass or those thin curtains that let some light in but still give you a bit of privacy.
Exactly. And, this whole transparency thing, it plays a huge role in design. Think about windows. They're designed to let in as much natural light as possible. Or packaging, you want to see what you're buying, right? But maybe not everything inside.
It's amazing, isn't it? Something we usually don't even think about, whether we can see through something or not. It's a key material property, and it's everywhere. Okay, ready for the next one?
Hit me with it.
All right. This one's like a kitchen sink science experiment waiting to happen. Remember when you were a kid and tried to dissolve, everything you could find in a glass of water?
Oh, yeah. I think we've all been there.
This textbook uses a similar example. It's Gulan again, and his mom is making lemonade, shikanji, dissolving sugar and salt in water. Super relatable, right?
Totally. And it gets you thinking some things are totally happy to disappear in a liquid, while others are like, nope, not happen.
Exactly. So that's solubility, right? Whether something can dissolve in a solvent, in this case, water.
Right.
Okay, but why should we even care if something dissolves or not? Seems kind of basic.
Well, because it actually matters a lot. Think about medicine, for example. How a pill dissolves in your stomach, it affects how your body absorbs the medicine, right? Or even in cooking, knowing how ingredients dissolve or don't is super important for getting the right textures and flavors.
Wow. Okay, so from lemonade to life-saving medications, solubility is everywhere.
It really is. You ready to tackle the last two properties this textbook covers? Or are we all materialed out for one day?
Bring it on. I'm ready for more. Let's talk mass and volume.
All right. This textbook, it illustrates these concepts in a really clever way. Imagine students trying to sit on their bags, some heavier than others, and then looking at how the water level changes when you fill identical glasses with different amounts of water. It's a great way to visualize these fundamental properties of matter, mass and volume.
Okay, mass and volume. I'll be honest, this always seemed a bit abstract to me back in school. Like, why do we care how much space something takes up or how heavy it is?
I get it, but honestly, understanding mass and volume, it's crucial for a ton of stuff. Think about shipping costs. They're usually based on weight, right?
Yeah.
Or building a bridge, you got to know how much the materials weigh to make sure the bridge can hold itself up, plus all the cars and trucks driving over it.
Right. Okay, that makes sense.
And volume. Imagine designing a water bottle without knowing how much liquid it needs to hold. It'd be a disaster.
True. So mass and volume, they're like the unsung heroes of the material world.
Exactly. And what's even cooler is that they're all connected. Mass, volume, hardness, transparency, even solubility, they all influence each other. It's like this intricate web that determines how a material behaves and what we can actually do with it.
Okay, so we've talked a lot about materials today, but this textbook, it also throws around the word matter. And I gotta be honest, I'm a little fuzzy on the difference. Are they the same thing or what?
It's a really good question, actually. It's subtle, but there is a difference. So this textbook, it defines matter as anything that takes up space and has mass. So basically, everything around us, you, me, this microphone, even the air.
Okay.
Materials, on the other hand, they're like specific types of matter, the stuff we use to actually make things.
So matter is like the big category, and then materials are like a smaller group within that.
Exactly. Think of it this way. The wood used to build a chair, the material, right? But the wood itself, it's made of matter. It has mass, volume, all those properties we've been talking about.
Okay, that makes sense. And knowing those properties hard, soft, transparent, opaque, it helps us figure out what to use for different things, right?
Exactly.
Yeah.
This textbook, it takes it a step further, though. Remember that section, Learning Further? It talks about recycling, how understanding material properties is super important for sorting and processing all that waste.
Oh, yeah, I never thought about it like that. But recyclers, they're basically material scientists. They have to know about melting points, densities, all that stuff.
Right. It's a cool connection. And it shows how the choices we make about materials, they have a big impact. Like the textbook mentions plastic, for example.
Oh, yeah, plastic. It's durable, waterproof, super versatile. But it also, like, sticks around forever.
Exactly. So it's not just about what we can make from materials, but also the impact of those choices. And that gets at some bigger questions the textbook brings up. How do these properties, the hardness, the transparency, how do they shape the design of the objects we use every single day?
Wow, I've never really thought about it like that. Like how the properties of the material affect not just how something works, but also how it looks, how it feels.
Exactly. Like the grain of a certain type of wood, how that makes a piece of furniture unique. Or think about smartphones, how sleek they are now because of advancements in material science. It's incredible. The materials we choose, they don't just affect how something works, they affect how it looks, how it feels, even how it makes us feel.
This deep dive has been amazing. I never thought I'd learn so much from a 6th grade science textbook.
It just goes to show you, sometimes the most basic concepts, they hold the most profound insights. And material science, it's not just in textbooks or labs, it's everywhere. It shapes our world in ways we don't even realize.
So true. Next time I grab a glass of water or send a text or even just sit on the couch, I'm going to be thinking about all the amazing materials that make it all possible. Thanks for joining me on this deep dive. Until next time, keep exploring the fascinating world around you.